Next page. A little more serious example this time. Go to example 1, page 271.
Chris. That's Louis.
Okay? We're going to study a relation via a graph. This relation is expressed graphically. Okay? So we have this graph. I'll try and sketch it here really quick. It goes like that. It goes up like that. And flat. And then goes pokey. Down to here, flat. And then down to the end there. And they say that the x-axis represents time, and the y-axis is distance from start. So the example says, wakeboarding has grown to be a popular sport. How many of you have wakeboarded before? Are you awesome at it? Or are you...
Mediocre. Yeah.
Yeah, I am pathetic at it. The graph shows the distance that a wakeboarder is from her starting point on Last Mountain Lake in Saskatchewan. Describe what the boarder is doing. So this particular graph shows the relationship between distance and time. How far away is the wakeboarder from where they started over time? Okay. To help things be a little more understandable, I'm going to label some points. We're going to label this initial point A, this point B, C, D, E, it's at the peak there, F, and G. Just so that we can talk about different segments of that graph properly. So, let's break this down. During the phase AB, what is happening? They're moving away from the start point. Try to be a little more specific.
Speed is slowly increasing.
The speed is slowly increasing. What likely is the wakeboarder doing? Are they on the board yet, doing flips and stuff like that? They're probably just getting up.
Oh, I know this.
Right? Okay, so let's write that down. Boarder is just getting up. Okay. B to C. B to C. What's happening?
It's getting further away.
They're getting further and further away from where they started. Are they on the board now? They're on the board. So B to C, they're probably on the board. Let me ask you, is the speed increasing or decreasing?
Increases. Well, it increases and then it revs down.
Just going from B to C. Is the speed increasing, decreasing, or is it constant?
It's constant.
It's constant. How do you know?
It's a straight line.
Because it's a straight line. It's increasing at the same rate the entire way. So imagine just the boat starting to speed up here. It reaches boarding speed. I don't know what the technical term is, but the speed that you have to go so the guy doesn't fall off. Okay, not too fast, not too slow, but just right so that the boarder can stay on. Okay, so BC, boat is traveling away from start at a constant speed. All right. Now let's look at C to D. C to D, this segment up here. What happened there?
Slow it down.
It's flat. It is not. He's not gaining any distance nor losing any distance in relation to where they started over a certain period of time.
The boarder fell over.
Fell over. Sitting in the water, And time is still going on, but he's not going anywhere. He's not moving further away, he's not moving closer. He fell in the water.
They're on a constant path.
Yeah, we're assuming they're in a straight line, right? Okay, so fell off the board. D to E next. Let's see if that makes sense in context of what happens next. What's going on here?
I think the border is getting up, so the gun.
Okay, yeah, they probably gun it, right? Because this is a pretty spike, or a pretty steep spike in distance covered. So they probably gun it, the border gets back up. I guess we assume that they're pretty good at getting on the wakeboard all of a sudden. Okay, so border gets back on. At a higher initial speed. Okay. E to F. What's happening E to F?
They fall off again?
Looks like
Just
it's
slow
an
down.
average speed.
Remember, this is how far they are away from the distance. So I'm getting further at a faster rate, not getting any further away, getting further again.
They probably
What's happening now?
Slowing down.
Is it just a constant
Go
rate?
straight.
Remember, this is not a relationship of speed. This is not faster and slower. This is further and closer.
Turning around.
They turned around. Okay? They turned around and they're now going back at a constant speed. Again, constant because that line is straight. Okay? So, turned around and headed back to start. At a constant rate or speed. F to G. Oh, I missed a point. Sorry. Let me just erase this. This I'm going to make G. And this I'm going to make H. Okay. Anyways, what's happening F to G?
Go down.
Fell down again. It's flat again, right? Okay, so F to G fell down again. In your notes, you'll just have to add G to H. What happens G to H?
Driving back at a constant rate.
They get back up, they drive home at a constant rate. Or back to where they started. Okay? So, gets back up and goes back to start at a constant rate. Awesome. Okay. Let's just take a brief look at the your turn at the bottom of that page there. Okay. And let's just talk about it here. We've got a graph, this time comparing what two things?
Speed and time.
Speed and time. Last time it was time and
Distance.
distance. And what is it modeling? What kind of phenomenon is it modeling?
Boat pulling a wakeboarder.
Same thing?
Yep.
Yep. Okay. So now this is a little bit different, right? You tell me, what's happening during this segment right here?
They're speeding up.
They're speeding up. They start at 0 speed and their speed goes up. Is it speed increasing constantly?
Yeah.
Yeah. Okay. What about at this point here? Did the guy fall off?
No.
No.
No. What's happening?
Just a constant speed.
Yeah, they're just staying at the same speed. Staying at a constant speed. You could call this here acceleration, constant acceleration. This would be constant speed. What about here?
He fell over.
Maybe he fell, but suddenly his speed bolted down to 0. Okay, probably fell off. This,
Got back on it.
accelerating again at a constant rate, back to where they were before. Uniform speed. This,
Slowly.
They're turning back now.
they're decelerating down to 0. We don't know if they're turning back. That's one thing we can't read from this graph. We don't know how far they are away from the start. They could have just like started at the dock, went out, accelerated, flatlined, biffed it, accelerated again, flatlined, and then just slowed down to a stop in the middle of the lake to fish. Because that's what you do when you suck at wakeboarding. Yeah. Good.